Hey, welcome back. In this lecture, let's understand who configures the OS Tick Timer. So this was the diagram we explained in our previous lecture, isn't it? So this actually summarizes what happens after the SysTick interrupt is triggered, which is our OS Tick Timer. But we forgot to understand one thing, who actually configures the OS Tick Timer or SysTick Timer. So let's explore that. This diagram helps you to understand where the OS Tick Timer gets initialized or where it gets configured. So this is a communication between two source codes, two source files. One is task.c and port.c. So I have already shown you how to locate the port.c because this is architecture specific code. Must be you must find this in your respective architecture folder, isn't it? And the task.c is actually related to FreeRTOS kernel. So this is a generic file. This is one of the source file of FreeRTOS kernel. And in the task.c, there is a function called vTaskStartScheduler. Okay, and that function internally calls the function called xPortStartScheduler. Okay, in the port.c, and in that function, three major things will happen. So first one is first initialize the SysTick interrupt priority to the lowest possible. Okay, that is priority configuration. So then loads the rate value into the SysTick timer. So this rate value will be loaded into the SysTick timer and enables the SysTick timer interrupt and starts the timer. Okay, so now let's get into the source code to understand this. Alright, so this is a code which we tested in our earlier lecture while I was showing you how you can quickly test your FreeRTOS task running on the hardware, right? So now this was our main file where we created two tasks. Okay, don't worry about task creation and all. We are going to explore that later. And then you have to start the scheduler to schedule these tasks which are created. Okay, so these are the task creations. Once they are created, they will not be running on the CPU. Okay, so you have to call this function, that is scheduler. You have to call the scheduler so that your task start executing. Okay, so now let's go to this function which is implemented in task.c. Okay, so this is task.c and this is a vstart scheduler. So now let's see what it does. It first creates the idle task. Okay, and after that, and it does various initializations. Okay, then read here, setting up the timer tick is hardware specific, isn't it? Because as I told you, ARM Cortex uses SysTick, AVR uses some other timer, MSP uses some other timer. So setting up the timer tick is always a hardware specific. This is not the headache of FreeRTOS kernel. Okay, so this is the headache of the architecture specific code. So what FreeRTOS does is it just calls this function. Okay, export start scheduler. So the port, the prefix port indicates that this function is architecture specific or port specific. Okay, so you have to implement this function according to your architecture. That's it. So now it will take you into the port.c, isn't it? So it will take you now into the port.c. So now we are in the port.c. Okay, so port.c is architecture specific code for the ARM Cortex M3 architecture, and here you can see make pendsv, call sv and SysTick the same priority as the kernel. Okay, so basically they are actually configuring the priority for the pendsv as well as for SysTick exception. Okay, after that, start the timer that generates the tick ISR. Okay, interrupts are disabled here already. Okay, that's okay. So start the timer that generates the tick ISR. So let's see what is implemented inside this function. Okay, so here, so we need not to worry about this section because this is valid if the mode is tickless. Okay, if you are using a tickless mode, then it is important. So basically we are not using tickless mode of the kernel. Okay, so directly you should come here. Okay, so in this line they are basically configuring the systic timer register, that is the load register, with the timeout value. Okay, so the timeout value is calculated by dividing the systic clock hertz. Okay, that is nothing but so this macro is nothing but the CPU clock hertz, okay, which is your microcontroller clock frequency divided by the tick rate hertz. Okay, so that value they are loading into the systic timer register, and after that they are enabling the systic clock, enabling the systic interrupt, and they are triggering the timer. So the FreeRTOS code structure is very simple to understand, and there are lots of comments, okay, they have included for each function to understand what exactly the function or line of code really does. So I request you to go through the FreeRTOS kernel, and if you have any doubt so far, then feel free to raise your question in the course discussion board. Okay, see you in the next lecture.